Hi guys, today we're going to talk about the moon, formation, its rotation and revolution, and phases. So we're going to break it down into a few different topics for the moon. So first, as you can see, I purposefully wore my favorite shirt, my Phases of the Moon shirt. So we're going to talk about that and how that works in a second here. So let's start just with this picture. Looks pretty apocalyptic. That is a theoretical idea that the moon was put into our orbit around the Earth when Earth was starting to form in its very early stages. So they suppose 4.5 billion years ago, there was a collision between a very large object and the then forming Earth. And they collided, and a lot of mass was shot off of the Earth, and we have, as a result, the moon. And there are similar compositions between the Earth and the moon, and that's why they think they are in some way related, if you want to call it that. Now, a really interesting thing about the orbit of the Earth, the moon around the Earth, is the way it actually moves. And this is in your reference table. It's the same exact solar system data chart. It's on the very bottom of it. And you'll notice that there are two things, a few things to take note of. Number one, the moon orbits the Earth in an eccentric orbit. It's 0.055, which is close to zero, which means it's mostly circular, but there are times when the moon is further away and when it's closer to the Earth, apogee and perigee. Remember, apogee being farther away, perigee being closer. And therefore, the moon actually, it does appear to be larger and smaller at different times in the month. The other thing that's really important here is this rotation and revolution. Notice that the period of revolution, in other words, the time it takes to go around the Earth, is 27.3 days. But also, you may not have known this, but the moon also spins. It has a rotation rate. And if you look at the numbers, they're identical. The rotation rate and the revolution rate are the same. And the best way to demonstrate that, I usually do this in the classroom, the best way to demonstrate that is to have somebody walk around and face somebody else, and it's kind of fun. But I'm going to show that in this video clip right here.
But it's rotating at a rate that matches the revolution, just so that only one side of the moon ever faces Earth. And that's exactly the situation we find ourselves in today.
Now, the reason that happens is because the center of gravity of the moon is actually on the near side, and it keeps it in its orbit facing the Earth all the time. That's why you always see the full moon and it always looks the same, and you might see this quote unquote man in the moon. We've been seeing that for years because the moon has always been facing us because of this rotation and revolution rate being the same. That's an important fact. Okay? Now, let's talk about phases. The moon obviously goes through a series of phases as it goes around the Earth. And a phase, just to identify what that is, a phase is the apparent shape of the moon, not the actual shape of the moon. The actual shape of the moon is a sphere. But the apparent shape is what we see. And that is due to the fact that there are two things going on. Number one, the moon is going around the Earth. It's revolving around the Earth every 27.3 days. So it takes 27.3 days for it to go all the way around the Earth. But it also reflects a lot of light. It doesn't give off any light of its own, so it's just bouncing light from the sun back to our eyes. So that reflection of light, as well as the revolution of the moon around the Earth, that's what causes phases. All right, I think the best way to kind of show you how the phases work is to show you this little simulator, and then I'm going to show you a video clip, which is pretty well done. So we can see the Earth, the moon, and the sun, and where the sun is located. Remember, the sun is an important part of this whole picture, and I'll talk about that a little bit later on. So what I'm going to do is I want you to look at the phase, and I want you to look at the position of the moon going around the Earth, and then we'll kind of break this down in a second. So I'm going to start this animation. Look at how the moon is going around the Earth. Obviously, the Earth spins every day. As the moon goes around the Earth, you can see it's getting brighter and brighter and brighter. We call that the waxing crescent. Okay, and then we get to this point where we're about 25% away through the cycle, and that's called the first quarter moon. This is called the waxing gibbous moon as it gets brighter and brighter, but it's not quite 100% yet. Once we get to the other side where we have sun, earth, moon, that's called full moon. And now we move our way back and it's getting dimmer and darker. That's called waning gibbous. as we get to the third quarter phase, which is right over here. We're 3/4 of the way done. Okay, so third quarter, and then we are in our waning crescent phase right now. As it gets dimmer and dimmer and dimmer, it has that crescent-like shape, which returns us all the way back to the other side 29.5 days later, and now we are at new moon again. Okay, so that's the entire cycle of phases animated. Now I want to show you a little video clip which demonstrates that, and I would have done this in the classroom.
We know that the moon orbits the Earth. So in this model, I'm going to get the moon, the foam ball, to orbit the Earth, my head. Notice that no matter where the moon is in its orbit, half of it is always lit up by the sun. But when the moon is in this position, I can't see any of the lighted side of the moon from Earth, my head. From this angle, you can see what I am seeing from Earth. We call this new moon. When it's new moon, we look up at the sky and we can't see the moon. It's there, but the side that's reflecting sunlight is away from us. Now, as I slowly make the moon orbit to my left, I can begin to see a tiny sliver of that lighted side. We call that a crescent moon. As the moon keeps orbiting, we can see more and more of that lighted side. We see half of the lighted half, which is a quarter moon. In this case, a first quarter moon. As we keep orbiting, we see almost the whole lighted side. We call that a gibbous moon. Then, when we can see the entire lighted half of the moon, that's a full moon. As the moon continues in its orbit, we begin to see less and less of that lighted side. We're back to a gibbous moon, but this time the light is on the opposite side. Then another quarter moon, last quarter moon to be exact. Another crescent, and finally back to new moon. And the cycle begins again.
All right, so back to this picture here. As you can see, this is a Regents style diagram of the exact same thing we were just looking at. But notice now the sun's over here. You got to always look for where the sun's rays are located. So this is the Earth. This is the moon going around the Earth. And we have these different numbers on here just to kind of give you some examples of questions that might be asked. So let's start with this moon right here. Okay, so this is Earth, and we're going to look at what we actually see. So we're taking the perspective of somebody standing on Earth looking at this moon. This side's lit up, this side's dark. So what we see is just this area of the moon, and you can see all I'm seeing in this area, it's all shaded. Everything's shaded, which means I can't see anything of the moon. It's completely dark. We call that the new moon. Okay, new. All right, now let's go to, clear the screen, and let's go to this next picture right here, which is number 8 in our diagram. It doesn't matter what numbers they are. This is what we're looking at from the Earth perspective. And you can see here, the side that is lit up is just this little tiny portion right here. Okay, and so this part is all dark, but there's a little tiny bit of light right here that I can see. So if I were to actually draw that, it would have a little tiny bit of light on the right-hand side. And so what that moon actually looks like is just a little tiny sliver like this that's lit up. And this is all dark over here. Okay, so my dark side is the left side. My bright side is the right side. That's important. Okay, that's called a waxing crescent. Waxing, by the way, means getting brighter. So waxing is going to be up here on the top of my diagram. Waxing. Okay. Now, the number 1 picture right here, I'm going to erase the board again. Let's look at what that is. And this is called the first quarter moon. We're a quarter of the way through the cycle. From our perspective, we're looking from the Earth up at the moon like this. this left-hand side is dark, shaded, and the right-hand side over there is lit up. That means it's half lit up and half dark. What that would look like, here's my moon, and the light side is the right side, and the left side is dark, so it looks like that, half lit up. In fact, it looks exactly like this picture right here. Okay, I'm going to erase the board again. Let's take a look at this one. This diagram number 2 in our picture. I'm going to draw what I see from the Earth perspective. And you can see there's a tiny little portion of this that is dark on the left-hand side. Most of it is lit up on the right-hand side. And if I were to draw what that moon looks like, it looks like this, where only a tiny portion of it is dark on the left-hand side. Most of it is lit up, okay? It's not 100% lit up, but it's more than half. And we call that a gibbous moon, a waxing gibbous moon, okay? Number 3 in our diagram right here, I'm going to erase the board again. Number 3 in our diagram, notice that all you're seeing in this perspective is all light. Okay, it's 100% lit up. There's no dark that we can see from our perspective, and that's called the full moon. Okay, when the Earth and the moon and the sun are all lined up like that. Okay, and that would just look like an open circle, an unshaded circle. All right, I'm going to just do a couple more. I don't want to do all of them, but in this, you have to almost turn the picture and change your perspective, like turn your head upside down and see what you're seeing from the perspective of the Earth. Okay, and if you look, this little tiny portion right here on the right-hand side is shaded. The left-hand side is mostly lit up. So if you turn your head and try to draw that, again, this is the moon. The side that's shaded is just a little bit of it on the right-hand side. The left-hand side is mostly lit up. This is called a waning gibbous moon. So the bottom part here, as it starts to get dimmer, we call that waning. Okay, and all these guys on the bottom are all waning until we get back to new moon over here. I'll draw, this is the last quarter moon where the light side is actually the left side. Let's just do this one right here. And if you look at this, there's a little tiny portion of this that's lit up on the left-hand side. Most of this is dark on the right-hand side. Again, you got to kind of turn your head. And so this guy right here is another crescent moon. The left-hand side is the lit up side this time, and it's mostly dark on the right-hand side. So that is a waning crescent moon. And then we get back to new. Okay? Now, if we go through our pictures here, let me just present again. Notice in this diagram, it's kind of reverse of what we were just looking at. Now the sun is on this side, and it kind of changes the order of things. In this case, it's the new moon over here on the left, okay, and the full moon's on the right. So you just kind of always look for where the sun is located. It's going to change your diagram slightly, okay? So again, these are all waxing, okay? Waxing getting brighter and waning getting dimmer. And this is kind of a cool animation that shows all of them. All right, so this is just a time-lapse image of the moon throughout a whole month. And it's really starting from right where it's dark right there, and it's getting brighter, 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 totally bright, and then getting dimmer, 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 and now it's back to new moon again. You can see this is a waxing crescent, getting brighter, 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 all the way to full moon right here, and then it starts to get dimmer and dimmer and dimmer and dimmer until you can't see it right here, okay? So this cycle of phases is, I always remember it this way, okay? If the light side of the moon is the right side of the moon, then it's getting brighter. That's called waxing. So if you look at all these pictures right here, the light side is the right side, it's getting brighter. If the light is on the right, it's getting bright. That's how I remember it. So you can see here, the light side is the right side. These are all waxing. So this is a waxing crescent. This is a first quarter approximately. That's a waxing gibbous moon. That's a full moon. And now these are all light side is on the left side. So this is waning, okay, waning, waning crescent over here, okay? And you can see that same thing here. Another way to remember it, another trick I learned, was imagine you could draw an imaginary line down the moon, and if you were to draw an imaginary line down the moon like this from top to bottom, and it would make a lowercase b for brighter. So you can see the line here, and this makes the light side makes a B, okay, for B for brighter or waxing. And if you did it with, it would make a lowercase d for dimmer down here. That one works okay. I like the light side as the bright side. Okay, if the light is on the right, it's getting bright. All right. So this is interesting because the whole entire cycle of phases takes about a month. Now, technically speaking, and this is another kind of phrase to remember, it takes 29.5 days to go from phase to phase. Phase to phase, 29 and a half days. So if you look, this is the months of May and June of 2020. So we're going to have a full moon this week on Friday. Now, the previous full moon was here on May 7th. Okay, so if I count, that's 7, 14, 21, 28, and then one more day, that's 29. And technically the full moon will happen in between here, between the 5th and the 6th. So it's 29 and a half days from full moon to full moon. The same is true with all the other phases of the moon. Okay, so for example, here's the last new moon, which was last week on the 22nd. Okay, and you can see, actually it's a couple weeks ago now. So that's 7, 14, 21, 28 days, 29 days and a half brings us right around here. Okay, so it's always 29 and a half days from phase to phase, which means we can make some predictions about when the next full moon will happen or when the next first quarter moon will happen. In fact, we have this all mapped out for ever. Okay, you can predict this into the future because the phases of the moon are cyclical and predictable, meaning they repeat in a regular fashion because the moon is always going around the earth the exact same way all the time. Okay, so phases of the moon are a cyclical event. So 29 and a half days from phase to phase. Now, you might be saying, well, what about that whole 27.3 days thing? I thought it only took 27.3 days to go around the earth. So why isn't it 27.3 days? Well, there's a difference between what we call a synodic period and a sidereal period. Sidereal period is the time it takes to revolve around the earth. Synodic is the time required for everything to line up relative to the sun. Okay? And remember, the sun is important in this whole picture because that's what's giving the light for the phase. So here's how it works. And if you don't understand this, don't worry about it. But remember, everything's moving. We got the earth moving around the sun, and we have the moon moving around the earth. And so if we want a new moon, we have sun, moon, earth, all lined up in a nice, neat line. As the moon goes around the earth, it takes about a month, right? But that means the earth is also moving around the sun in that month time period. So if we want everything to line up, think about this. Here's the moon currently. It takes 27.3 days for it to go all the way around, okay, to get back to that stage where it was right here, where it's in this orbit. But you need to go that extra little bit, an extra 2.2 days to get to this point where it's all lined up again in that nice, neat line to get to our new moon. So it takes a little bit more time for that synodic month, and 29.5 days, remember, from phase to phase. All right, so let's just do some practice questions with the moon phases. This is a question from August of 2011. You can see there's a calendar there with some major phases of the moon. You can see the new moon, first quarter, full moon, and then last quarter moon as we go from here to here. Notice it's 29 and a half days from this phase to this phase, the new to the new. Okay, so that's something to take note of. We have to figure out what date this phase occurred. Now, if you look at that, you'll notice that the light side is actually the left side. There's a little bit of a sliver of dark on the right. This is the what we call the waning gibbous moon. It's not quite full, and the light side is the left side, so it's after the full moon, so which it has to be after the 16th. That means get rid of choice 1 and choice 2. Now, is it after the last quarter? No, because it's not only half lit up. In fact, it's in between the full moon and the last quarter moon, and therefore it's got to be somewhere in this week here, and it looks like it's the 19th. That would make sense. Okay, so the 19th is the answer, number 3. Take a look at this question. It says, which date will the next first quarter moon phase occur? Next first quarter. So this is the full moon, and the next major phase would be the first quarter moon after that, and that would be somewhere in this range. It would be 29 and a half days after this date right here, July 8th. So you could count like 7, 14, 21, 28. It would be somewhere around here, about a week after. Okay, so if we count, this is August 1st, 2nd, 3rd, 4th, 5th, 6th. So it makes sense it would be August 6th. That would be choice number 1 there. Okay, this is actually my picture. I just changed the question slightly to use my picture here. This phase right here, we have to figure out what it is and where it is on this diagram. So if you look at it, the light is on the right, so it's getting bright. That is a waxing crescent moon. And this picture was taken last week.
The moon sometimes looks like a sea, but you can't eat that.
Where is that on our diagram? Well, okay, here's the sun over here. Here's the moon. Here's the earth. When we have the moon right here, that's the new moon. That means it's just after that. So go counterclockwise around. It's just starting to get bright. That would be picture number 8 in this diagram. Okay, the light side is just on the right. All right, same diagram. Different question. It says, state the number of days it takes to go from the full moon to the next full moon. Remember, from phase to phase is 29 and a half days. Therefore, 29.5 days is the correct answer. Last question. Why do we always see the same side of the moon? Well, that's because the rotation rate and the revolution rate are identical. It revolves and rotates 27.3 days at that rate. So it's the same, therefore we always see the same side. Okay? And you're going to get some more practice questions today. If you have any questions about anything, just let me know.